Spider-Man movie can be watched by kids. Conclusion, Spider-Man movie is a cartoon. So the question is like, does this like have to be true? Okay. So it looks like the kind of the there's like cartoons. Think of the innermost circle as being cartoons.
Yeah.
And then we know that all cartoons can be watched by kids. We know that like kids kind of surround cartoons.
Okay.
And then the question is the Spider-Man movie can be watched by kids. Does that mean that it has to be a cartoon? Or could it be, for example, here?
Yeah, it could be separate.
Could be separate. So this is really a Venn diagram, but it's sort of it's possible. Like there could be an overlap between them, which I think is what they're looking for. I'm just looking at the picture here again of it. It says X can be anywhere in K, and X, I guess, is the conclusion.
Yeah.
So this is not a valid conclusion that it is a cartoon, because we don't know whether it is or isn't. It could be, but it's not guaranteed to be.
Yeah.
That's why we say invalid. And then also it's not sound. It could be sound, which doesn't sound right, but a sound argument could also be invalid. But typically it's invalid, not sound, or it's valid and sound.
Yeah.
Hopefully that's clear. All right. Number 2 is some sort of a conversion thing here. Grab that. Did you get a conversion sheet of numbers on the exam? Okay. Find the scale ratio of 1 inch on the map represents 25 miles. Okay. On the ground, 1 feet equals 12 inches. Okay. So you start with, how do they want? So like typically they tell you like whether it's like inches to miles. So I guess we do that. 1 to 25. Huh. This is just a little odd the way it's presented. Okay, let's start with 25 miles. Typically, you start with the bigger number, 25 miles. We know that 1 mile is 5,280 feet. You know you're going to be using both conversions. And then 1 foot is 12 inches. So that gives you some number. Okay, and if you do grab a calculator, you'll find it's 1,584,000. Like that. So 1 inch on the map is 1,584,000 inches in the real world.
Yeah.
Miles canceled miles, feet canceled feet. Okay.
Yep. That's what the answer was. Okay.
All right. So let's look at number 3. Were you able to finish the exams with enough time to check your answers when you took them?
Yeah. And the classes are pretty short. It's like 50 minutes, but I get 2 hours for the final. So
oh, wow. Okay.
It'll be okay.
All right. So here we go. We got a concrete patio. It's 27 feet by 18 feet. But it's also 0.5 inches thick. So you can drop that down if you want. All right, so the volume is needed here. The volume is needed, but we need to convert it to cubic yards. I found it's better. Well, it's up to you. That you can either do this. You can either do the volume in feet and then deal with the cubic yards, or because it's not too bad to convert from feet to yards, you can divide each by 3, and that will give you the volume there.
Okay.
So if you don't like that, let me know. We can do it that way. That is the volume though. It's not the final answer. The volume, when you do that calculation, is 9 times 6, 18. Okay, it ends up being 3
Okay.
yards. And then the cost is $125. And actually the unit's in the wrong place. So $125 per yard. So you have 3 yards, the yards cancel, and that's, wait, this is not right. Sorry, this is 9. Sorry, 9.
Mhm. Yeah.
And then 9 yards.
Okay.
Number 4.
Yeah.
Yesterday, the price of Google stock increased by 20%. Today, it decreased by 6%. By what percentage has the price changed over the 2-day period? Round your answer to the nearest tenth. It's often good to choose a numerical value that you started with. For example, which you don't have to, but this is usually what students do, and I think it's pretty helpful. So if it increased by 20%, that means it's now worth 120. But then it increased, but now it decreased by 6%. So to find the decrease, it's a little bit harder. So we actually multiplied by 1.2 here for the increase. When it goes down by 6%, it's actually like multiplying by 0.94. It's 1 minus the percent as a decimal.
Okay. Yeah.
Is that comfortable? Something it's okay with? All right. So 120 times 0.94 is 112.8. The percentage change is a formula. It's the new minus the old over the old. So that ends up being 112.8 minus 100 over 100, which I think is consistent with your answer. Yes, 12.8%.
Okay.
If this were negative, that would mean it's a decrease. They do it with X. They just say X times 1.2 and then X times 0.94. I'd use a number.
Yeah.
You do want to indicate that it's a positive or it's a increase. Oh, and it even asks you that.
Yeah, it's an increase because
Yes.
positive. Yeah.
Great.
Okay. Number 5 is, yeah. Okay.
Dog trainer. How are your dogs?
Absolute relative. Good.
All right. Dog trainer measures the height of your dog and gets 92 centimeters, but your dog was moving during the measurement. When you measure the height of your dog at home, you find that their actual height is 88 centimeters. Find the absolute error and the relative error of the measurement. Okay. The absolute error is a formula again. You'll see this in your science courses or lab. It's the absolute value of the approximate minus the true value.
Okay.
So it's your approximate is 92, but the true value is 8. So it's 4 centimeters. And then the relative error is the approximate minus the true, all divided by the true. So in this case, it's 4 over 88. Round to the nearest hundredth. Sometimes they want this as a percentage. I'm not seeing that language in here. And then you would multiply by 100 before rounding, but it doesn't really say.
Yeah, the absolute error is in centimeters, and then the relative error is in percentage.
Right. So there's this implication here that you're supposed to multiply by 100. That becomes 4.55%.
Oh wait, they did the they did the relative error as, oh yeah, that's right. The
Yeah.
4/88. Yeah. Okay. Got it.
All right, so 6, last question here. This is what I was expecting with the Venn diagram, not the logic flow. This is the more traditional Venn diagram. In a class of 40 students, 20 students like swimming, 18 students like drawing, and 5 do not like either. Ooh, that's a little variation on it. So you typically draw your 2 circles here.
Yeah.
Swimmers, drawers, and the neither are the ones that are out here. So we know that there's 5 that don't like either. There's 40 total. So that means that there are 35 in the 2 circles. Okay, but we know that this one is 20 and this one is 18, and there's some overlap. So like we know that there's 20 and 18, but there's some overlap here in the middle. That overlap comes from adding 20 and 18 and subtracting from 35. So subtracting 35 from that, because that's how many are left over that should be in there. So that gives you 3 in the middle. And since 20 students like swimming, the whole circle has to add up to 20, 17, and 3 add up to 20. Drawers, you got the 3 and the 18, so that's 15. And then you just do another calculation here to make sure everything here adds up to 240, and that the numbers in the circle add up to the 35. Once you have that, the rest of the problems are just grabbing numbers from the Venn diagram.
It's like, how many people like swimming? And yeah.
Yes. Yes.
Do those.
Okay. You sure? Because they're really exciting. The one little wrinkle in this one is that they said do not like either. That's here. Most standard problems, they tell you like both.
Yeah.
How many like both, and then you fill that in. But just get this filled out, and then you can answer all the questions from there. All right, we can move on to exam 2 now.
Yes.
Just letting those load up.
This is the APR stuff.
All right, number 1. Looks like you're doing a calculator, a lot of calculator stuff here. How much would you have to deposit today if the bank offers an interest rate of 2.25% compounded continuously, and you would like to have $30,000 in 25 years? So that continuously is the key word there. That tells you that you're using PERT, which I guess your instructor does it slightly differently. He writes A equals PE to the APR times Y. APR is the annual percentage rate as a decimal. So you have to decide, well, which values am I given? Well, we want $30,000 in 25 years. That's T, that's A. We don't know how much we're starting with. And the APR, again, you convert that to a decimal, so you divide by 100. 0.0225 times 25. You solve for P by dividing. Are you allowed to use a normal TI 83, 84 in this course? Are you using the same calculator you had last year for this?
Yeah, it's 53,333. That's not right.
That doesn't seem right, because it should be a lot less than you started with. And I have yeah, so that's not right either. 0.0. Okay. Sorry, maybe you said this number. I was fumbling around with the calculator. This is what I see as a starting value.
Okay. What do you do with the E?
That's on the calculator there. I can share a virtual TI-83 if you'd like to show you how to do this. The E is under the LN, second LN.
Okay. Oh, yeah, there it is. Let me just make sure I can do this. Oh yeah, okay, I got it.
All right. Very good. Okay, so on to the next question here.
Wait.
All right, Sarah invests $3,700 in an account that earns an interest APR of 1.3 compounded monthly. Assume that after the initial deposit, no withdrawals and no deposits are made. Find the APY and its percentage yield. Keep 2 decimal places in your final answer. All right, so on your first page there, your instructor kind of gives it to you. So I don't know why they don't just give it to you. So I don't want to do this. The APY, which is a weird way of putting it, but it's 1 plus your interest rate divided by n to the power of n. And n this time is the number of times that's compounded.
Okay.
So in your problem, it's 1 plus 0.013 monthly 12 to the power of 12. Wait, you guys do it differently, maybe. Oh no, okay, you guys, that is right. All right, now there's a bit more. This you end up having to subtract 1 from it.
Okay.
Which is slightly different than how you see it in your answers, but it does work out the same. And then you end up multiplying by 100 to get back to a percentage.
Okay.
Let me know if you have any questions about how to calculate that.
It's just a matter of putting in the right parentheses. This doesn't work. All right. Can you walk me through it?
Yes, so let me go to my calculator here, share my screen. All right, so you're seeing this calculator, hopefully.
Yeah.
All right, one of the things you might do is just try to do it in pieces. So like the 1 plus 0.013 divided by 12 to the power of 12. Okay, and just make sure that that works. And then you can hit second entry, which is down here under enter, to grab it and edit it if you want. So notice the next thing is to subtract 1. I know you could just subtract 1 from your answer, but this is like if you want to do it all at once like that, and you see that it did subtract 1. You can hit second entry again to grab it back. This time though, we're going to add those additional parentheses. So second insert parenthesis, put the parentheses at the end and multiply by 100.
Okay.
So the answer is 1.31, and that is a little bit higher than your interest rate that they're giving you in the problem. The APY is always just a tiny bit higher.
Mm-hmm.
So 1.31 kind of as a check there. All right. So on to part B.
Okay. For
B.
8 years.
What's the balance after 8 years? Okay. So this time basically what we did is kind of unrelated to this. You go back to the original amounts here. So you start with 3,700. 1 plus your interest rate is 0.013. It's not the one you found in the previous problem. And then it's 12 times 8. When you put this in your calculator, make sure your exponent is in parentheses.
Okay. Before we go on, can you just remind me what each variable
Sorry.
stands
Yeah, I
for?
should have done that. Let's go. I've been trying to avoid using your instructor's formulas because they're awkward. There we go. We're using this formula here. Okay. And the P is the principal. It's what you're starting with.
Okay.
The APR is your interest rate as a decimal. N is the number of compounding periods, which in this case, monthly meant 12. If it said annually, that's 1, weekly is 52, quarterly 4. And then Y is the number of years, which in your problem is 8.
Okay. And then if it's like compounding every day, I'd put 365 for N.
Yes, exactly.
Okay. All right. I always mess up. Okay. Back to the problem.
All right, so just a calculation now. It's not a lot, but it does go up a little bit. Were you able to calculate this, or do you need me to show you this in the calculator?
I've just been writing down the
Okay.
variables.
I'm in a hurry. I'm in a hurry to get through your assignments.
Yeah, if you can do it while I think I know how to do it now.
All right, so here's what it looks like when you go to the calculator. Like I mentioned, you really need parentheses around the exponents. I know some of the, like if you've got an 84, sometimes it'll do it kind of in more of the math mode where you can see it. You don't do this awful inline thing, but that does sync up with the answer that you're given there.
Okay. Well, yes.
All right, 8 years after buying 80 shares of some stock for $50 per share, you sell the entire stock for 5,200. What were your total and annual returns on this investment? Keep two decimal places in your final answers. All right. Okay, so this one's it's not really a formula. It's a little bit more of just like like what you had, what you started with and what you now have. So your purchase is 80 times 50. So you spend $4,000 to buy, right? And then you sold, you sold for 5,200, which means your profit, or not profit, I guess your total return is 5,200 minus 4,000, which is 1,200. Your annual return is how much you got per year.
Okay.
All right. But hang on here. This is what I was looking here. It's not, they mean it's not written well, but it's not asking about the dollar amount. It's asking about the percentage amounts, which is not really clearly described here.
Mhm.
So it's really the percent return and then annual percent return.
Okay.
So your total percent return is the new minus the old over the old. So it's worth 5,200. The old was 4,000. You divide by 4,000.
Mhm.
So this ends up being, I think, 30%. It's 0.3 converts to decimal. Now the annual return is different. And the annual return is like a little bit more complicated to explain. It's not dividing it by 8. It's a different calculation. And hopefully that was made clear in class.
Mhm.
So the annual return is in some ways kind of working one of the equations backwards. Now your instructor gives you an annual return equation, which is the future amount over the present value amount, 1 over the number of years minus 1. So in your problem, that's 5,200 over 4,000 to the 1 over 8 power minus 1. So if you don't like that, and I might be with you, where I'm not sure you like that, but we can maybe work it through from another equation. This is not the one this is not given though at the top of the exam. So you'd have to know this on your own.
Is there a better way to put it that I would maybe remember it easier?
Yeah, it comes from it basically comes from the A equals P A to the T. And so it's like you're solving by dividing by P. And then to undo the T, it's the 1 over T power. So it comes from this. You take 1 over T from both sides. And then you're like, well, what about the 1? Well, A is really 1 plus your growth rate. So your A is really 1 plus R, and that's where you subtract 1 to get it.
Okay.
It's kind of like Half-Life, where you can either remember to do the how to calculate each time with a formula, or you have to go through it each time. I don't know. Like, this is really specific. I wouldn't think this would be on a final exam, if you're asking my opinion.
Yeah.
The other problems would be
seem way more important.
Yeah. And that's how you should study. They're not looking for the deepest knowledge in every single thing here. So when you do this calculation, just looking back, it ends up being when you multiply by 100, it ends up being 3.33%.
Okay. Right.
All right. So progress has slowed a little. We were doing one exam in 16 minutes, but this one's going to take a little longer.
We can skip one of these. There's a loan one, and then maybe let's just skip to 6.
Okay. All right, you need a mortgage. I should say you want needs are different. You want a mortgage of $400,000. You can get a 30-year, that's T, fixed rate at an APR of 3.8% compounded monthly with a closing cost of 1.5 points. So 1.5 points refers to and $600.
Yeah, that's like the percentage point.
Yeah,
thing.
so you take that and multiply 400,000 times the 0.015. But I
Okay.
guess you're also adding $600. Maybe that's closing costs to
Yeah.
it. Anyway, determine your total closing costs. Oh, that's that part. Monthly payment over the term of the loan and your amount of interest paid over the loan term in dollars and percent terms. Keep 2 decimal places in your answer. So this is I believe this is 6,600. Yes, this is 6,000 plus 600. So that's your closing costs. They do not, you pay those out of pocket typically, or sometimes the seller pays them in some scenarios, but you're still mortgaging $400,000. You're getting a loan on that.
Mhm.
So there's a next thing here where it says to determine the monthly payments. With these, you got to make sure you're getting all the things that it's asking for. So your payment formula is given. It's kind of awful, frankly.
I know I don't like the way it's set.
Yeah.
I'm like, that's way too.
Yeah, they use most textbooks use I instead of APR
Uh-huh.
to make it easier, but you are given all this information, which is
Yeah.
so P is your principal, so it's what
Uh-huh.
you're starting with. So that's the 400,000. Your APR is 0.038, but you have to divide it by 12. And then on the bottom here, 1 minus 1 plus 0.038 divided by 12. And then it's not formatted well, but this is an exponent. So it's minus n, which is 12 months times 30 years, or minus 360. So I would recommend trying to put this in your calculator.
Okay.
Just it pretty much the way it's entered is fine, because at the top there's no adding and subtracting. So you're just dividing here.
Long. Okay. Okay. So top part, I got 12, 6, 6, and then okay, I got 1,862.84. Does that sound right?
It's close enough. The instructor wrote 1863.83.
Okay.
That's close enough. I mean, if we're a real bank, we would make sure it was perfect, but we'll go with that. So that's the monthly payment. So you can check that one off. Now, the next thing it asks for is the amount of interest paid over the loan term, okay? And they say in dollars and percent terms. So the first thing to do for that part is to actually take your monthly payment and multiply it by 360 months.
Okay.
And that's going to be a fairly large number. And this, I think, is actually the important number that very few people look at when they're buying a home, which is how much are you actually paying for it?
Yeah. Okay.
Okay, and you'll see here that it's again, you might be slightly off. That's okay. They're grading based on whether you're in the ballpark of this. Okay. So for a $400,000 home, this is what you're actually paying.
Okay.
So by borrowing the money, you're giving up. You're not having to give up that money right now, but you're paying back more than that. So the actual interest, what they're asking for, is this amount subtracted by the original value of the home.
Mhm.
So you're paying $270,000, $270,978.80 in interest. That's the dollar amount.
Okay.
And depending on how you feel, that could be a lot, or you could say, yeah, I like it. All right.
Okay.
Now, as a percent, it's the interest that you have divided by the total there.
Okay.
That's about 68%.
Okay.
And interest rates have gone up. Maybe you're a little too young to be thinking about home purchase, but we're seeing like basically this number is approaching 100,000 or 100% of the loan value with higher interest rates right now.
Okay. 68%. That's pretty high. All
And
right.
the same thing applies to cars. If you
Oh.
buy it, you might, that $40,000 car, you might end up paying 60,000 for. It doesn't look like such a good deal.
Yeah.
All right, that's a different class though. So on to the third exam.
Yeah. Let me just look through it and see which one I am confused about. All right. Because I just took this one, so I kind of know which ones I did well on. Number one, I can do that. Maybe number two.
Okay, let me give me a moment to get those opened. You said number two?
Correct.
Okay. Suppose that 20 rabbits are born every month. After 4 months, there are 150 rabbits. What is the independent variable? What is the dependent variable? Okay, there's a lot going on here. The way that I interpret this is that every month there's 20 more rabbits.
Mhm.
And I hope that's the way you read it. What's a little bit bothersome is this 4 months there's 150, implying that there must have been some to start.
Yeah.
Like you had 70 rabbits to start, and then 20 times 4 gets you to 150.
Mm,
I'm seeing a pattern here with your instructor that he likes the backwards questions, especially with that Venn diagram. The backwards are the ones where you get kind of the end result and you have to work backwards to find the preliminary result. So the independent variable here is typically time, months, and the dependent variable is the number of rabbits.
Okay. Yeah.
Okay. Now, is this linear exponential? That answer is based on whether it's the same amount, which is linear. Exponentials are a rate. So you'll see an increasing or decreasing amount each month.
Okay.
Write an equation to model the situation. That's, your slope mx plus b, because it is linear. If it was exponential, that's the pat equation.
Yeah.
So your slope is however much it's going up by each month, which is 20. We should use t instead of x. And then b is how many rabbits you were starting with, which is 70.
Okay. All right, that one's good. Let's do ones that there's a doubling time. Let's do number 5.
This looks like a short exam.
Yeah, really short.
All right, a population of bacteria has a half-life of 20 hours. If the initial population of bacteria is 3,000, how long will it take to reach 600 bacteria? Round to the nearest ones, should say ones place. All right, one thing I'm going to check here. I mentioned the equation pat earlier. You guys probably are using PERT in this one, but you could actually use either. I don't know if I see.
Yeah, so
what time 20 hours Q0. Okay, no, so your instructor does not do that. All right, that's important. So the way your instructor does this, Q equals Q0. This is the half time.
Yeah.
And then it's T over whatever the actual half time is. They use big T in a lot of these.
Yeah.
So the Q0 here is 3,000. Okay, so it's half because that right there.
Yeah.
And then the 20 is that one there. There's other ways to, like I mentioned, there's this one, but this one on the left's a little better. So you're figuring out when this equals 600. Okay, and so you're dividing both sides by 3,000. So that's 1/5 equals 1/2 t over 20. To get a variable out of an exponent, use logarithms. Natural logarithms probably preferred here. The exponent comes out in front when you use logarithms. And then you divide both sides by the logarithm. You're still trying to solve for t. So you divide by natural log of 1/2. So that's t over 20 equals natural log of 1/5 over natural log of 1/2.
Okay.
And then to solve for t, you got to multiply both sides by 20. There is a way to figure out if your answer is reasonable. And I'll show you that here in a moment. But you'd have to go to your calculator and get that. 40. So the answer is 46.4. So 46 hours, because it says rounds to the ones place. The way to decide if your answer is reasonable is to go back and look at and just make a quick table. Okay, so when you start, there's 3,000, and every 20 hours it doubles. So in 20 hours it's 1,500, 40 hours it's 750. So it's going to be between 40 and 60 hours that it gets to 600. So it's going to be closer to 40 to kind of double check your answer, make sure it's reasonable. See if we can do part B.
Yeah, rate of change would be fast.
That is a percentage. Find the approximate and the exact rate of change. Okay. The approximate.
It's like dividing by 70, right? Is that how you do it? Oh, that's a half.
I'm looking at the answers because I don't know how this has been
Done.
accomplished.
Let me
Yeah.
see which one.
I don't see it. So this might be something to ask the instructor about why this is why is it 70 over P? Unless it's not a 70, but it sure looks like it. There's I don't even want to say that because it doesn't make sense. But this other one is more, the other one is more appropriate. Q 0. We talked about this earlier as being a to the power of t, but a is really, it can be 1 plus r for growth, or it's 1 minus r for decay. And since you're getting smaller, that's why they're using 1 minus r in this problem. So whatever you're starting with, you're trying to use the fact that the half-life means it went in half. So if you prefer numbers, which I think most students do, it's like 3,000 to get to 1,500. When you divide by 3,000, you get the 1/2 on the left.
Oh, yeah, okay.
And then we know that that is in 20 years. T is 20. So you undo that with the power of 1 over 20, 1/2, 1 over 20 equals 1 minus r. And then to get r by itself, lonesome self, you move it left and then you bring the other thing over. So r ends up being 1 minus 1/2 to the 1 over 20 power, like that. So it says it's about 3.4%. I'm not sure about the approximation. There's a rule of 72.
Yeah, I found it. The approximation is the principal equals 70 over the half-life. And so that was just 70 divided by 20 to get 3.5.
I see. So that, yeah, that's a thing from your class.
Yeah.
Cool. All right, well, we do have to stop here. We are out of time.